We're going to do 674b, which was 41 to 87 odd, and we did the first half yesterday. So we stopped at 53, and we'll do the second half today, which is exactly the same. We're just going to use radians instead of degrees. Okay. So take a look at 62. All of these have a domain from 0 inclusive all the way up to 2 pi exclusive. So 0 does count. Let's do number 62. The sine of x is equal to the cosine or negative cosine of x. Well, when are the sine and the cosine the same value? 45 degrees. Okay. So we have 4 options for a 45-degree reference angle. So this is pi over 4, and this is 3 pi over 4, and 5 pi over 4, and 7 pi over 4. Those are my only choices. Okay, and we want the sine to be positive. When is the sine positive? In 1 and 2. Okay, and then when is the cosine negative? In quadrant 2 and in quadrant 3. So which quadrant has a positive sine equal to a negative cosine? Quadrant 2. So it would be 3 pi over 4. Okay. Number 64. The sine of x plus the cosecant of x is equal to 2. What is the cosecant? Well, I'm going to change the cosecant to be 1 over the sine of x. When will the sine plus the 1 over the sine equal 2? Right, one of the right angle angles. So when is the sine equal to positive 1? At pi over 2. So basically, I need to do 1 plus 1 over 1. So that would be pi over 2. So the answer is pi over 2. Okay, take a look at 66. The secant of x plus the tangent of x is equal to 1. 1 over the cosine of x plus the tangent of x. Yeah, we could change that. That's not a bad idea. Sine of x over the cosine of x equals 1. What values of sine and cosine will make this work? We need the cosine to equal 1, and we need the sine to equal 0. Is there a place where the cosine is 1 and the sine is 0? At 0, or 2 pi? Why is it 0 and not 2 pi? 2 pi is not part of the provided domain. It's got to be 0. Okay? All right, 68. The cosecant of x minus the cotangent of x equals root 3 over 3. Oh, wow. Cost. Ah, wow. Just kidding. So the cotangent of x. So this is 1 over the sine of x minus cosine of x over the sine of x equals the square root of 3 over 3. And, well, square root of 3 over 3. How am I going to make that work? We know the sine of x can't be 0. Okay. What is root 3 over 3 can be switched to 1 over root 3. So this is 1 over root 3. Well, let's try it. Let's make cosine 0 and see what happens. So the cosine equals 0 when the sine is equal to 1 or negative 1, right? So where is the cosine equal to 0? Here or here. So when the cosine is 0, sine is plus or minus 1. Will that work? No, that doesn't work. Okay? So it's going to have to be a 1/2 and a root 3 over 2 angle. Okay, so um, let's look in quadrant 1 at 30 degrees, which is root 3 over 2 comma 1/2. Let's see if that angle works. So the cosine is root 3 over 2, and the sine is 1/2. So 1 divided by 0.5 minus root 3 over 2 divided by 0.5. Okay. What do we do from here? Well, they're both over 1/2. So 1 minus root 3 over 2 divided by 1/2. Flip and times. So 1 minus root 3 over 2 times 2 over 1. Distribute the 2. 2 minus square root of 3. Does that equal 1 over root 3? So 2 minus the square root of 3 is 0.26, and 1 divided by square root of 3, no. Actually, nope, not quite. It almost looked twice as big. So that didn't work. Now what should we try? Try a 60-degree angle, or pi over 3. That's a better way to say it. So this is 1/2 root 3 over 2. So 1 divided by root 3 over 2. Oh, I typed that in wrong, didn't I? No, I didn't. Never mind. Minus 1/2 divided by root 3 over 2. I have a common denominator already. And 1 minus 1/2 is 1/2 divided by root 3 over 2. Flip and times 2 over root 3. Done. So now let's check. It works at pi over 3. Will the same thing happen in quadrant 2? Well, no, sorry. We got 1 over root 3, which is root 3 over 3. I just matched it to that. Okay. So it works in quadrant 1 at pi thirds. Will it work in quadrant 2? No, because the cosine is negative and the sine is positive. Okay. Will it work in quadrant 3? So if I had, let's see, this would be negative, and this would be negative, and this would be negative. So those would cancel. or sorry, no, well, let's not do it that way. So negative 1 over root 3 over 2 plus, nope, it would be minus 1/2 over negative over root 3 over 2, and it's not going to work. It'll end up being negative. Okay, will it work in quadrant 4? Nope, so it's just pi thirds. Well, you can kind of reason it out. And it just depends on the problem. The only way to get good at these is to do a whole bunch. So number 70. 2 sine of x plus the cosecant of x equals 3. So 2 sine of x plus 1 over the sine of x equals 3. Sine has to be 1. 2 times 1 plus 1 over 1 equals 3. Which angle gives me a sine value of 1? Pi over 2. What about 3 pi over 2 is a negative 1? Will that work? 2 times negative 1 plus 1 over negative 1 would be negative 3. So that one doesn't work. It would just be pi over 2. Okay, 72. Sine of 2x equals root 3 sine of x. What would you do here? Yeah, I guess you could do it that way. So the sine of some angle times 2 is equal to root 3 times the sine of the angle. Okay. So we need an angle that we can double, and the sine of the double angle is equal to root 3 times the sine of the original angle. Okay. Well, we're working in radians, so we really only have 4 choices. Right? We either have pi over 6, pi over 4, pi over 3, or one of the right angles. Okay? So let's try a right angle. Let's try 90. So will 90 work? So if x equals 90, what happens when I plug it in there? The sine of 180 is 0. So the sine of 180 is 0. Is 0 equal, well, it's not going to work. And then what do I plug in there? 90. The sine of 90 is 1, and root 3 times 1 is root 3. So that doesn't work. 90 does not work. Okay, let's try 45. So x equals 45. So if I put 45 in there, I get 2 times the sine of 90, which is 1. So I get 1 equals, oh, no. The multiply by 2 happens to the angle. So we're taking 45, plugging it in, timesing it by 2, getting 90. The sine of 90 is 1. If I put 45 in there, root 2 over 2. What is root 3 times root 2 over 2? Root 6 over 2, which is not 1. Right. Right? It's not equal to 1. Okay, let me get rid of some of this mess. So let's try pi over 6, which is this angle right here. Okay, pi over 6. So what happens when I plug pi over 6 in there? 2 times pi over 6 is pi thirds. The sine of pi thirds is root 3 over 2. Okay? What happens when I put pi sixths right there? The sine of pi over 6 is 1/2. Root 3 over 2 times 1/2 is root 3 over 2. Okay? So one of my answers is pi over 6. Okay? Does that happen again somewhere else? Probably in 3. Why 3? Well, so let's check quadrant 2. I'm thinking it's 2. So let's try 2. What is the angle in quadrant 2 we're going to look at? So 5 pi over 6. Okay. Now the right side is easier, so let's do that one first. If I put this in here, maybe. So if I plug 5 pi over 6 into that right side, I get root 3 times 1/2, which is root 3 over 2. Right? What happens, let's do this in degrees. What is 5 pi over 6 in degrees? 150. So what happens when I plug 150 in there? I get 300. What's the sine of 300? Negative root 3 over 2. Did that work? No. So let's check. It would be 7 pi over 6. So 7 pi over 6 in here is going to give me negative 1/2. Well, the doubled angle can be out of the range, but theta can't be out of, or x can't be out of the range. So when I plug it in there, I get root 3 over negative 1 times negative 1/2, right? That's what happens when I plug 7 pi over 6 in there. When I plug it in there, so 7 pi over 6 doubled is 14 pi over 6, which is pi thirds, and the sine of pi thirds, positive root 3 over 2. That didn't work. Okay, let's try quadrant 4. So this is 11 pi over 6. So if I put 11 pi over 6 here, I get negative 1/2, right? So this is root 3 times negative 1/2. When I plug 11 pi over 6 here, I get 22 pi over 6, which is 300 degrees. And the sine of 300 degrees is negative root 3 over 2. So I was wrong and you were wrong. 1 and 4. So pi over 6 and 11 pi over 6 both work. Okay, let's do one of the squareds. Look at 82. 2 cosine squared is equal to the sine of x plus 1. We might be able to do that. Let's try avoiding it first. Right, that's what, well, or a Pythagorean identity. So let's not change it right now. Let's just reason through it for a second. Okay, so this is 2 times a over h squared equal to o over h plus 1. That's kind of what we're looking at. Is there some fraction that I can square and multiply by 2 and have it equal to an o over h plus 1? Well, let's just try one. Let's try 30 degrees. 2 times, what's the cosine of 30 degrees? Root 3 over 2 squared. The sine of 30 degrees? Okay. What is root 3 over 2 squared? 3 over 4. 2 times 3 over 4 equal to 1.5. Is that true? Yes, it is. Right? Let's try pi over 3. So for pi over 3, I would have 2 times 1/2 squared equals root 3 over 2 plus 1. 1/2 squared is 1/4. 1/4 of 2 is 0.5. Is that true? No, that didn't work. 2 times 3/4. It would be 6 over 4. Yeah, it would be. Okay. So pi over 3 didn't work. What about pi over 4? 2 times root 2 over 2 squared equals root 2 over 2 plus 1. So that would be 2 times 2 over 4. Is that equal to the square root of 2 over 2 plus 1? No, that didn't work. What about 90 degrees? So that would be 2 times 0 squared equals 1 plus 1. Is that true? No. Uh, so at 180, 2 times 1 squared plus 0 or equals 0 plus 1. Is that true? Or wait, one of them's negative. This would be negative. No, I lied. That's positive. This is negative. So that one didn't work. So let's look at pi over 6. Pi over 6 worked. So we know that this angle pi over 6 worked because we got 1.5 equals 1.5. If we did the same thing in quadrant 2, what's different about quadrant 2 from quadrant 1? Cosine is negative. Is that going to affect this? No, because it gets squared. So we know that pi over 6 works. We also know that 5 pi over 6 works. What about 7 pi over 6? It won't work because the cosine is negative, but the squared gets rid of the negative, and the sine is negative, and it remains negative. So this one doesn't work. What about 11 pi over 6? Same problem. The cosine is positive, and the sine is negative, so you end up with opposite values. Okay? All right. That's all I can teach you. Good luck.